Hello everybody. What's up Ketchup? How are you Pikachu? Namaste ab kaise hai? Today we are gonna learn about bending tests. Before I start with our topic, first I will show you a video about a day in the life of a sheet metal worker.
Never know what the week holds. You might be doing one thing one day, and then the next day you might be somewhere else.
It makes me feel just proud to know that I'm part of a bigger thing, not just coming to work every day and getting a paycheck.
Are you ready to discover a career that will teach you the skills you need to become a master craftsman? A career that will equip you with a diverse skill set that you can use for the rest of your life? If you are ready to commit to doing the hard work it will require to positively change your life, an incredible career awaits you right now in the sheet metal industry. Not only will you be taught various crafts by master instructors, but you will have the opportunity to earn great wages while receiving benefits that will give you financial security now and for your future.
The kind of work I do every day is forming and bending metal to make different fittings. It's basically feet to the floor and get it all done for the next 8 hours and get off by 2 and home by 3, take care of kids.
Okay, now we are gonna go back with our topic. First, what is bending? To force an object, especially a long or thin one, from a straight form into a curved or angular one, or from a curved or angular form into some different form. What is bending test? Assures that a metal is ductile and not inclined to brittleness. Actual bending accomplished by either a constant pressure or by blows of a hammer. Procedure. Metals are subjected to cold bending through an angle of 180 degrees over a pin equal to the diameter thickness of the test specimen without cracking. These specimens take both parallel to and across the grain. For sharp bending, it is preferable to make all bends across the grain. For sheet or strip stock, length should be 6 inches. Width should be 1 inch. With full thickness, edges must be rounded with a file, otherwise cracks may form on rough or rugged parts. Heavy plates or shape. Width should be 1 to 2.5 inches. Suitable length and full thickness. Specimen rectangular in cross section. Corners broken with a smooth file. Rods and bars submitted to bend test in their full section. Forging stock. Length at least 6 inches. Cross section 1 by 1.5 inch. Edges rounded to a 1 radius. And now I will show you a video of forging stock.
This video is brought to you by Skillshare. Get exact percentage of carbon present in the material has dramatic results on the final material that is permeated into nearly every technology we use in our lives. But I failed to tell you why that simple addition of carbon has such a huge effect on the iron, turning it from a relatively weak material to one capable of launching an industrial revolution, which is what we're going to learn today. Much of our knowledge in crafting steel was passed down over the centuries from blacksmith to blacksmith, creating tools for their communities. So to learn more about this amazing material and how blacksmiths carefully tailor its material properties, I visited ALIAC Steel's workshop to create my own knife from scratch. We started our forging process with round stock 1055 steel with 0.55% carbon content, and placed it in the forge and gradually shaped it with a power hammer to a rectangular bar that could be more precisely shaped into the shape of our blade using a 3-pound hammer that my wee arms struggled to swing after an hour. Once we roughed out the shape, we began to grind and refine our blade, eventually producing our blade blank that would be later grinded to its final shape But before that could happen, we needed to perform some metallurgy wizardry through the heat treatment process. To drive home how important this step is, we tested 4 samples of the same material at different stages of the heat treatment process. This was our sample before the heat treatment process, which you will quickly see was the weakest of the bunch.
As you can see,
This is
he's
the normalized
using the
sample,
hammer
which was ductile
to
with a
bend
low
the
yield
steel.
stress. It took several hammer blows, which it absorbed through plastic deformation. Not
This is
ideal
normalized.
characteristics for a sword or knife. Next, we tested our quench-hardened sample, which is stupid and dangerous and should not be tried at home. This fractured explosively and tore a hole through ALIAC's reflector. Finally, we tested the tempered material, which absorbed every hammer blow with minimal plastic deformation and only broke when we cut a notch into the material to create a stress concentration point. This material is tough, capable of absorbing energy without deforming permanently, and hard, allowing it to resist damage to the cutting edge. It is the ideal material for a blade. If any of these terms confused you, I created a video called Material Properties 101 that you can check out. Centered cube each grade 2, which doesn't change meaningfully with heat treatment. This is where alloying with carbon comes in. But to explore this, let's look at our phase diagram for carbon steel. On this diagram, commonly called body-centered cubic, the start of our heat treatment cycle to the end. The first step is called normalization. Normalization's primary function is to relieve internal stresses and strains that form during the forging process and return the material to its original crystal structure before forging began. It's effectively a reset button for the steel and creates a nice even grain size and distribution, increasing its strength. Here we place the knife inside a steel tube to prevent the metal from receiving heat directly from the flame, but instead a more even radiative heat from the tube. Once it reaches this transition temperature, we let it soak to give the crystal structure time to settle. The next step in normalization is to allow the steel to slowly air cool. What happens now depends on the carbon content. If we take a 0.8% carbon steel, no, hang on,
Okay,
this video.
now we will go to heavy material. 1 and 1.5 inches to over, taken from a point midway between the center and the outer surface of the stock. Let's go to reverse bend test, usually performed on round steel wires. Wires must be at least 10 inches long. And for the procedure, wire is held in a vise on bend testing machine and bent back and forth 90 degrees, each way through a total angle of 180 degrees. The jaws of the vise are rounded to the required radius. And this is the procedure. For 90 degrees bend equals 1 bend. Small wires is to 50 bends. Heavy wires should be 7 bends. For flattening test, type of bending test applied to tubing, tube is flattened sideways and inspected for defects. Length of tube equals 2 times its diameter. Bronze tubing, thickness of flattened tube must not exceed 3 times the wall thickness. Here are some examples. This is an example of flattening a stainless pipe. As you can see, stainless steel pipe reduced to less than 1. Again, thank you. That's all, folks.